Okay, so since we don't have a Q&A session coming up, I wanted to go ahead and post a worked out solution and talk through free response item 4. So first thing, we've got a cylinder with a diameter of 2. All right, so right there, I'm just going to kind of make a note to myself that my radius is going to be 1. All right, because that may simplify some formulas for us as we go through, and that radius is going to be consistent top to bottom. It continues on, as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height, h, of the water in the barrel with respect to time is modeled by this equation, right, where h is measured in feet and t is measured in seconds. All right, and then they tell us the volume formula. College Board is really good about this. They don't want it to be a memorization-based test. All right, so part A says find the rate of change of the volume of water in the barrel with respect to the time when the height of the water is 4. So this one is kind of screaming related rates at us. All right, so in A, I'm going to go to my know, find, relationship strategy that we did in the related rates section. All right, so one thing I know is I know dH dt is negative 1/10 root h. All right, I want to find the change in volume, so dV dt. All right, and I want to find that specifically when h equals 4. All right, so now I want to find a relationship. So I go back and I'm going to look at the two variables in play. And the two variables in play here are the h in the first, the known, and the v in the find. All right, so those are related by our volume formula. So volume equals pi r squared h. Now, we know from the problem that r is consistently 1 here, so I'm going to simplify that to v equals pi h. All right, so now I want to relate dv and dh, so I'm going to take the derivative of this with respect to t. So I have dv dt equals pi dh dt. All right, but I'm going to substitute because I know dh dt. So dv dt equals pi times dh dt, which is negative 1/10 root h. And I want to evaluate that specifically when h equals 4. So I have pi times negative 1/10 root 4. All right, and I can clean that up a little bit. So I've got root 4 is 2. 2 over 10 is 1/5. So I have negative pi over 5. All right, and then I look back to the question. It said find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. All right, indicate units of measure. So first thing I'm going to deal with is I'm going to deal with units. So this is dV dt. All right, they told me feet and seconds were the two measurements. So volume is going to be feet cubed. So dV is feet cubed. And then t is our time unit, which would be seconds. All right, now in most normal situations, all right, this answer I have written here would be totally sufficient. All right, for College Board, it is not sufficient. All right, so if I don't do the next thing, I would lose a point on the AP exam. All right, so what I need to do is I need to put this in context. All right, so we're going to just frame it off the question. So the rate of change of the volume of water in the barrel with respect to time is negative pi over 5 feet cubed per second when h equals 4. And I'm going to go ahead and box that in. And that would be my final answer for part A. Right, so part A was really a beginning to end related rates. The only twist that they had in there is the DHDT that we knew was a function rather than just being one data value. Like a lot of times we know DHDT is 5 and we can just plug 5 into our formula and we see the DHDT. This time we had to plug an expression into it. So that's part A explained. I'll come back in the next video with part B, and then after that part C.